In this video, we'll look at a piece of open source Java code which is known to be badly written from both a security perspective as well as from a usability perspective. We use the AI tool ChatGPT to help us create a more secure version of the code that produces fewer runtime errors as well as more helpful error messages for the users when things go wrong. Along the way, we'll discuss some fundamental security concepts like input sanitization and error checking. As a bonus, we'll look at the code using IntelliJ IDEA, write some test cases, and see how the old code performs against the new code. Let's get started. For this coding example, I've chosen a very simple piece of code called 8-ball. If you've ever used the static analysis tool from Fortify, it's one of the sample files that comes bundled with the deployment. The file is available to us on Fortify's public GitHub page. 8-ball consists of one class that reads a file passed into it on the command line, does some manipulation of the file name with the modulus operator if the file name is numeric, and then it writes out the first 1024 characters to the console. It's a short and sweet application, but it's not written particularly well. There's no validation, no real error handling, and if you run the code, you'll get stack traces and other unexpected behavior, as we'll see when we run our test code later in this video. To get started, let's make a copy of the code and bring it into ChatGPT to see how we can improve it. Here we are in ChatGPT. First, let's have ChatGPT tell us about the code. Let's type, explain this code, and then paste in the code that we copied from GitHub. In the first paragraph, it does a really nice job of explaining what the code does. This is a really handy feature and something to consider using when you're presented with code you don't understand and want to know what it's doing. Next, let's see what it thinks about the security of this code. We'll ask, is it written securely? And here we go. It responds by saying the code has several potential security vulnerabilities and lists them. Number 1, the number of command line arguments are not checked. Number 2, the code doesn't check to see if the file exists or if the account running the application has permission to read the file before attempting to open it. Number 3, the size of the file is not checked. And it says buffer overflow can happen. That's really not a concern the way we might expect with an application written in C or C++, for example, but it can result in some ugly output, as we'll see when we get to the coding section. Finally, the input's not validated. It mentions an input validation vulnerability. The real vulnerability we might see here is path traversal. Using the code as it's written, a user could traverse the file system and look at files they shouldn't be able to see. Keep in mind this is a toy application, and for the most part, if it was ever used, an attacker would never have direct access to run the application in the manner we will. But all the issues ChatGPT points out are valid lessons and things we should keep in mind when writing any code for our projects. Let's ask ChatGPT to create a secure version of the code by typing, rewrite the code so it's secure. And here it goes. It adds a check for the number of arguments and will terminate the application if none are provided. In the next fix, it checks to see if the file exists and if we have permission to read it. Notice it uses the older Java I/O API instead of new I/O. We could have asked it to rewrite the code with new I/O, and it would have happily done so. Next in our rewrite, it opens the file, reads the entire contents, has error handling, catches the exception, and even uses the try with resources statement to ensure the file reader is closed. Wow, a really impressive first revision. Notice in the last line of the description, it says sanitizing input is recommended to make the app more secure. So let's ask it to make that change. We'll type, add code to sanitize user input and handle exceptions properly. And in just a moment, ChatGPT updates our code to reflect that change. It adds a call to a method called sanitize input and then checks the return value. If it's null, it prints an error message and exits the application. At the bottom, it created the sanitize input method. The code uses a regular expression to check the input for alphanumeric values only. Anything else is rejected. This is an example of a whitelist, sometimes called an allow list. Using it, we specify only the strings that are allowed, in this case, uppercase and lowercase A through Z, and the numbers 0 through 9. Any other characters are rejected. So if a malicious user tries to pass in .. to traverse the directory structure, they won't be able to. Nice job, ChatGPT. Let's switch gears here and take a look at the old code and the new code side by side in IntelliJ, run some test cases, and see how the old and new code performs. Here we are in IntelliJ IDEA. First up is the original code we got from GitHub. There's nothing much to see here, so let's move on. Next, Let's look at the first version of 8-Ball that ChatGPT rewrote for us. Looks like a lot of interesting new things, but it's hard to see what the old code is versus the new. So let's use one of the cool features of IntelliJ and compare the old and new code side by side. To get this view, simply select two files in the project panel and click Ctrl-D in Windows or Command-D in a Mac to get this view. On the left side is the old original 8-Ball code, and on the right is the first version of the rewritten code. In this view, everything that has a white background is unchanged between the two files. Everything that's blue is similar to, but has some differences between the two files. And everything that's green is net new on the right side. So let's take a look. We can see right off the bat where ChatGPT made the changes to check for the number of arguments that were passed in. If the number is not equal to 1, we print a message and execute the return statement, which terminates the application. In the next major block of code, we see ChatGPT really didn't make any changes, but broke up the assignment file name slightly. Really no big deal. There is an empty catch block, so at least we don't print the misleading error message anymore. In the final block below is where we see extensive changes. When the file is opened, we now see a completely different means for opening the file. We check its existence, and we check to see if we can read the file before we process it. And then down below in the green, we've got some error handling if the file is empty, and notice we're also able to handle the situation where the file is more than 1024 bytes long. Let's look at the second version of the code that ChatGPT created for us. If you recall, we asked it to sanitize the input. Once again, it's tough to really get a lot from this without having something to compare it to. So let's use the comparison feature in IntelliJ once again. Here we're comparing on the left panel the first version of the secure 8-Ball that ChatGPT created for us, and on the right is the second version that ChatGPT created. And once again, everything in white is common, everything in blue is altered, and everything in green is net new. The major changes are around the sanitization of the input. We call the sanitize method, and if the method returns null, we print a message and then exit the application. Down below, we see the sanitize input method that was created for us, using the regex to make sure that we only have alphanumeric strings and deny all other characters. And finally, to run the test, I've created two additional files. The first file is called 1. It's just an empty file. File number 2 is 2,000 characters of content that I created just so the application would have something to read. This will make more sense in just a moment when we look at our test cases. And then one last file I created in the IDEA projects directory one level up. I created a file called secretfile.txt. We'll take a quick look at that. I have my super secret password set to ABC123, which is clearly not super secret or a good password or something you should store in plain text. But it's fine for the testing we'll be doing in just a moment. Let's close all that, and let's take a quick look at our tests. I created tests for both the original 8-Ball application and the same test for the second version of the secure 8-Ball version that ChatGPT created for us. Our first file is called 8-Ball text file path traversal. It calls the original 8-Ball application. For our command line parameter, we'll pass in .. secretfile.txt, which is the file we just looked at. Because this version of the application allows path manipulation, the application will dump the contents of our file to the console. In the second test, called secure 8-Ball 02 text file plus path traversal, I'll pass the same text file location to the secure version of 8-Ball and see how it handles the file. Next, I have a test called 8-Ball no arguments. It calls the original 8-Ball code with no arguments. There's a corresponding test called secure 8-Ball 02 no arguments, where we make the call with the secure version of 8-Ball and no arguments. Our next test pair is called 8-Ball empty file and secure 8-Ball empty file 02. For both tests, we'll pass in a file that exists but has no content. Next is 8-Ball 2000 file secure and insecure. In this test, we pass the file that we looked at earlier called number 2, which contains 2,000 characters of data, and we'll see how it's handled. And finally, we have 8-Ball missing file secure and insecure. For this test, we pass in the name of a non-existent file called 999 to see how each version of 8-Ball handles the situation. Okay, let's run the test. First, for the original 8-Ball code, when we pass in secretfile.txt up one level in the directory structure, the application first prints out an invalid message statement because our file name is not numeric, and then it happily prints out the contents of our secret file, not preventing the exploit of the path manipulation vulnerability in this code. Now let's run the secure version of that code with the same input. When we do, it gives us an error message about the format of the input and exits gracefully. Nice. Keep in mind, if the secret file was in the same directory where our application was located, we could have printed out the contents. The new code does nothing to prevent that. What it does prevent is us or any malicious user from dumping the contents of any file they like anywhere in the directory hierarchy. Next, we'll run the insecure version of the code with no arguments, and we get an ugly stack trace. Now let's run the secure version of the code with no arguments. Here we get a nice error message asking us to provide valid input. Now let's run our test where we pass in an empty file that exists. We don't get an error message, but we do get the contents of the character buffer, which is all nulls, printed out. It's very ugly, but it's really no problem. Next, we'll run the secure version. We don't get an error message. However, it silently executes the code and returns no output. Definitely more graceful than the first version. Next, let's pass in the file with 2,000 characters to the original code. It works, but it may not be obvious that it cuts off the output, so you see just a portion of the file. Not technically wrong, depending on the use case for our application. But now let's try the secure version. When we run that code, we see the entire file contents dumped out. This is probably what our business users really wanted when they wrote our requirement. Finally, let's pass the original code to a file that's specified but not present. We get a big stack trace. Doing the same thing with the secure version of the code, we get a nice error message saying the file couldn't be read. Alright, so what's the lesson here? First, ChatGPT is an amazing tool, and it can help you fix insecure or broken code. But it's not perfect. It doesn't understand our use cases, yet, and it doesn't always use the latest features of the language. ChatGPT is not an excuse to be lazy. It's not going to write code for you. If anything, it's a call to action for you to become a better programmer. Using ChatGPT and your skills to guide it, you'll be able to create some really well-written, secure, and more stable applications in record time. If you enjoyed this video, please subscribe to be alerted when new content's available. Thanks for watching, and remember to always begin secure.